All right, today we're going to be diving into 3 different types of parallelograms. We're going to be looking at rectangles, rhombus, and squares. We're going to look at what they look like, what attributes they have, and then we're going to be solving some problems about them. So our first shape here is the rectangle. With this, it is a parallelogram. So all of the attributes of a parallelogram are still true. The only difference here is it's a parallelogram with 4 right angles. So parallelograms, we know their angles, the opposite angles are congruent and the consecutive angles add up to 180. That's still true here. These just have special angles. So in this picture, that's the first thing we're going to draw here is we have right angles. So all 4 of these are right angles. All right, so we've got the 4 right angles. Another thing we have here is we know that opposite sides are still congruent. So this side is the same as this side, where this side is the same as this side. And we're going to look at the diagonal. So a diagonal is when it goes from one opposite side to the other with these angles. So there's a diagonal. Try to make that a straight line there. And there's a diagonal. So you notice the diagonals kind of connect opposite angles. So in a rectangle, these diagonals are congruent. Which is going to be the exact same length. And if you remember before with parallelograms, the diagonals, all right, are going to bisect each other, which means this is the same as this. And since the diagonals are equal, they're all going to be the exact same length here. And the reason why this is a really great process here is because if you look at these triangles, it makes all of these triangles right here, so this triangle and the other ones, these are all isosceles triangles. So we can do a lot of information there once we know that those are isosceles, and we can do a lot more math with it. All right, so that is what the rectangle is. Up next, we have the rhombus. What makes the rhombus unique? It is also still a parallelogram. But this has 4 congruent sides. So what that means is this side is the same as this one, and this one, and this one. So all of the sides are congruent. So when we're looking at this, again, we know the opposite angles are going to be congruent and so on and so forth. So I'm going to draw in the diagonals real quick. So we're going to kind of analyze what happens when we do this. So when we draw those diagonals in, all right, your diagonals are actually going to be perpendicular. And what that means or tells us, if they're perpendicular, that means that this angle, and this angle, they're all right angles, which means we now have 4 little right triangles going on. Another thing this tells us is that the diagonals bisect those interior angles. So we know that this angle is the same as this angle, and that this angle is the same as this angle. And since it is parallelogram, that means opposite angles are still equal. So we know that these are equal. We know that these are equal. So it tells us a lot of information here. Now, the great thing about this is, if you notice, we don't have little isosceles triangles anymore, but all 4 of these triangles are the exact same triangle. So you have 4 congruent triangles here. So if you know information about one triangle, you can kind of replicate it to all the other ones. All right, the very last shape we're gonna look at here is the square. Now the square is kind of what we call like the perfect shape here. It's a combination of actually the rhombus and the rectangle. So this is still a parallelogram. But it gets right angles from the rectangle and 4 congruent sides from the rhombus. So it's taking those key features from these two shapes above here, the right angles and the 4 equal sides, and kind of combine them into what we call the square then. So the square has all the exact same properties as the two above. So all properties of a rectangle and a rhombus. So let's first start with the properties of a rectangle. If you remember the properties of a rectangle, it has 4 right angles and the diagonals are congruent. So I'm going to mark in my right angles. It also says the diagonals are congruent, so I'm going to draw in my diagonals. And since those are congruent, we know that this will be the same as this, and this, and this. We also have the properties from the rhombus, which says that diagonals are perpendicular, which means the angles where the diagonals are meeting are going to be 90 degrees. We also know the diagonals bisect those interior angles. And the good thing is, with this at least, since they bisect the interior angles, each angle is 90 degrees. So if we do 90 degrees divided by 2, that means each of these angles is 45 degrees in here. And the same thing goes to, it creates those 4 congruent triangles, and each of those triangles are going to be right triangles as well. Oh, and also from the rhombus, all of the sides are going to be congruent. So we also have those little isosceles triangles from the rectangle. So we're going to be using all these properties to help us solve for problems. So here's what it says: find the measurement of angle DAC in the square. So let's find where DAC is first. So D to A to C. So we're trying to figure out what this angle is right here. So let's think about what we know about the angles in a square. We know that all of the interior angles are 90 degrees. Okay. And we know, since it's a square, that that diagonal is actually cutting that angle in half. So we know that this angle is actually going to be 45 degrees. So the measurement of angle DAC is 45 degrees. All right, example 2, find RV if, and it says SW is 3x plus 2 and ST is 10x minus 8, and this is a rectangle. So we have to remember the properties of a rectangle to help us out here. I'm going to label what I know. I know SW is 3x plus 2 and ST, so this whole diagonal here, is 10x minus 8. Okay, so we know what that part is there, and we don't know what the other part is, that WT, but we know the whole thing. Now, if you remember back to our rectangles, they say the diagonals are congruent and they get cut in half. So if we know that this half right here, we can automatically assume it's going to be the exact same as our other portion. So if I know that SW is 3x plus 2, I also know that WT is also 3x plus 2. So now I can use my segment addition property. 3x plus 2 plus 3x plus 2 equals the 10x minus 8. If I combine like terms, I get 6x plus 4 equals 10x minus 8. I'm going to subtract 6x from both sides, and then add 8 to both sides. Then divide by 4, and I get x equals 3. Now again, that's not what they want. That they want us to find RV. Now RV is the entire diagonal. Now remember, in a rectangle, the diagonals are congruent. So if I plug RV, or if I plug this x in to this 10x plus minus 8, I'll get my value. So 10 times 3 minus 8. 10 times 3 is 30. 30 minus 8 is 22. So RV is 22. All right, last one. We have our rhombus here. They want us to find angle GHJ. So G to H to J. So we're finding this little angle right up here. Now they give us the angle here. They give us this 74. If we were in a rhombus, we know that these are all going to be right triangles. So we know that this is 90, this is 90, this is 90, and this is 90. We also know that those diagonals are going to be cutting or bisecting those interior angles. So if this is 74 on this half, this one's going to be 74. And remember, since it's still a parallelogram, opposite angles are going to be congruent as well. So now our goal is to find just this little top angle here. And since that is a little triangle, we can do 180 minus 90 minus 74, which will give me 16. So the measurement of angle GHJ is 16 degrees. And technically, I can put the 16s on all the remaining angles.